Okay, so this is the first of four short videos which provide an introduction to the naming and drawing of organic molecules. This is intended for my private chemistry students, and it's something I ask you to do before we begin working through the organic chemistry portion of your syllabus. Okay, so the naming of organic molecules, the fancy name for naming is nomenclature. And the drawing of a molecule is a drawing of a molecule is a representation of it. And a drawing, of course, is a two-dimensional representation. And we can make three-dimensional representations. For example, a ball and stick model, which you've probably done in class at some point. And you'll see in the document today and in the workbook, I have many pictures of ball and stick representations of molecules. So, to begin this introduction, we first learn about alkanes. Alkanes are simple organic molecules which just have carbons and hydrogens, and all the carbons make single bonds with other carbons, and the carbons also make single bonds with hydrogens. And we do this first because it provides a foundation for all other naming. If you understand alkanes, then you'll be able to understand how to begin to name other molecules. So in this first part, we will work through the naming of the first 10 straight chain alkanes, and we'll pick up the prefixes for the first 10 of any series of molecules based on the number of carbon atoms. In part 2, we will learn how to name cycloalkanes. In part 3, branch chain alkanes. And in part 4, branch cycloalkanes. All right, with that, let's dive in. So here we have a picture of a ball and stick representation of methane. This has molecular formula CH4, and there isn't really much more in terms of representing it. This is a simple molecule. This is certainly one of the simplest of all organic molecules. Okay, this next molecule is called ethane, and its molecular formula is there are 2 carbons and there are 6 hydrogens. And the other way to think about that is say, look, okay, well, there's a carbon and 3 hydrogens, and there's another carbon and 3 hydrogens, CH3. Okay. So this form of representation, this is called the condensed structural formula, and it clearly gives us more information than the molecular formula because it gives us a sense, the one on the right there, this one, the condensed structural formula, gives us a sense of how the atoms are connected to each other in the molecule, whilst in the molecular formula C2H6 we don't have any sense of that directly. There's a third way to represent this molecule, which is called the structural representation. So that thing in green is the condensed structural representation. Here then is the structural representation. I'll highlight that in orange. It's the structural representation, and that gives you all the connection information that you can see in the ball and stick model. So why bother with ball and stick models? Well, ball and stick models give you information about how those bonds and atoms are arranged in three-dimensional space, whilst the structural representation, the one in orange, gives you the sense of connection between the atoms, but doesn't provide much information about how it's arranged in 3D space. Moving down the information ladder, the ball and stick model gives us the most. The structural representation gives us some of that. The condensed structural formula, the one in green, gives us a condensed version of the orange. The condensed structural formula is a condensed version of the structural representation. And finally, we have the molecular formula, C2H6, where we've lost all of the connection information. Yeah. Okay, so that's the first two alkanes. The next one has 3 carbon atoms, and this is called propane, Propane. Okay, it has molecular formula C3. If you count the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. There are 8. Okay. The structural representation is this. It shows how the atoms in the molecule are connected. And finally, we have the condensed structural representation, which will be CH3. That's that bit. Then we have that bit, which is CH2. And finally, we have this bit, CH3. Okay. So the one in green, we use the same green. Lime green. Okay, this one in green, that's the condensed structural formula. The one in orange is the structural representation, and the one in yellow again is the molecular formula. Okay, so those are the first 3 alkanes. Methane, 1 carbon. Ethane, 2 carbons. Propane, 3 carbons. Okay, next one, 4 carbons, it's called butane. The molecular formula is C4, and if you go through and count the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we find there's 10. Okay. The structural representation is this. And then the condensed structural representation, by the same kind of logic as we use for propane, it will be CH3, CH2, CH2, CH3. Okay. These names, methane, ethane, propane, and butane, have arisen for historical reasons. You know, if one could reset the world, one might use more logical names, such as all the other names which follow. When we have 5 carbons, this is called pentane, as in, you know, penta, 5, pentathlon, pentagon. Okay, this has molecular formula C5. If you go through and count, you'll find that there are 12 hydrogen atoms. The structural representation looks like this. 5 carbons, a straight line. So this is the straight chain alkane with 5 carbon atoms. Okay. And we could then write the condensed structural formula. We could write mirroring what we have with butane. We'd have an extra CH2 group there. It's a pain to write out CH3, CH2, 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 CH3. And so we can condense the condensed formula. We could say this, it's CH3 bracket CH2 3 times, then CH3. Okay. All right, here is hexane. Hexagon, 6. The molecular formula is C6H14. if you count the hydrogen atoms. I'm not going to draw the structural representation. I'm sure you can figure it out. The condensed structural representation is CH3, CH2 4 times and CH3. Okay, but I will now introduce another form of representation, which is called the skeletal formula. Okay, so here's the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. That by itself is a representation of this molecule, which is called the skeletal formula. And the idea is at the end of each of those line segments, there's a carbon, and then we put on each carbon as many hydrogens as is necessary in order to ensure that each carbon has 4 bonds. So on this first carbon, there is 1, 2, 3 hydrogens implicitly. On the second carbon, there are 2 hydrogens. On this third carbon, there are another 2 hydrogens. On the fourth carbon, 2 hydrogens. On the fifth carbon, 2 hydrogens. And on the sixth carbon, 3 hydrogens also. Okay, now when I just drew that, I made a point of pausing on the first carbon and putting that dot there. That dot is not part of the representation. So the true skeletal form of this molecule is just this jagged line. 1, 2, 3, 4. So that is the skeletal form of hexane. And you can see that's a very fast way of drawing this molecule. Okay, so that's the first 6 straight chain hydrocarbons. 1 carbon methane, 2 carbons ethane, 3 carbons propane, 4 carbons butane, 5 carbons pentane, 6 carbons hexane, 7 carbons is called heptane, as in the heptathlon. Okay. It has molecular formula C7H16. It has condensed structural formula CH3, CH2 5 times CH3. And it has skeletal formula like that. 8 carbon atoms, octane. C8H18. Condensed structural formula CH3, CH2 6, CH3. And skeletal formula draw that right. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's right. Good. 9 carbons, nonane. C9H20. CH3, CH2, 7, CH3. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the skeletal formula in black. And finally, decane, as in decade. 10. C10H22. CH3, CH2, 8, CH3. And the skeletal formula 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay, so there is the first 10 straight chain alkanes. 1 carbon methane, 2 carbons ethane, 3 carbons propane, 4 carbons butane, 5 carbons pentane, 6 carbons hexane, 7 carbons heptane, 8 carbons octane, 9 carbons nonane, 10 carbons decane. Okay. And there's a few ways to represent it, these molecules. So here we have a picture of a ball and stick model. We can have the molecular formula, which just gives you the total number of carbon and hydrogens. So for example, in butane, C4H10 is the molecular formula. We can have the structural representation, which shows the connection between all the atoms in the molecule. That's the ones highlighted in orange, or again here. For example, that's the structural representation, or this one. Okay. We can have the condensed structural representation, which condenses the orange down into the green. Okay. And finally, we can also represent the molecule by using the skeletal structure, where we have these line segments. The ends of each line segment represents the position of a carbon atom, and the hydrogens are implicit using the rule that each carbon atom makes 4 bonds. Yep, so in these straight chain alkanes, if you have a carbon on the end, it only makes 1 other bond with another carbon, so there must be 3 hydrogens on each one of those carbons on the end. Whilst if you have a carbon in the middle of these straight chain alkanes, they have 2 bonds with other carbons, and therefore they make 2 bonds with hydrogens. Okay, so that is part 1, and you definitely need to learn these names, and you should also be able to represent any of these molecules using either the molecular formula, the structural representation, the condensed structural representation, or the skeletal form.